Hello, I'm Nola Donato. I'm a senior principal engineer with Samsung Research Labs. This is Tom Flynn. He is the director of augmented reality and virtual reality at Samsung Research Labs, and together we are going to take you on an augmented reality adventure. So if you want to be a superstar AR developer and you want to go on this adventure with us, first you need a software environment that's friendly to AR. And what we're going to show you is our new 3D engine, the XR SDK. Some of you who have done VR development might know this engine previously as the Gear VR framework. And we're going to show you how it integrates with an augmented reality platform that exists today by Google on Android called ARCore. To do this, you need a headset that supports AR. We might talk about this a bit later. Tom will introduce it. For now, our demo is going to show what it would look like on a headset, but we're using pass-through video so that you can see the scenery that he sees. And we have provided some training and access for you because we're having a hackathon at the end of SDC and a workshop right after. So we'll talk to you about this, and maybe you want to come join us on the rest of our adventure after this talk. First, let's introduce the XR SDK. It's a familiar engine because it's been around for about 3 years. It was previously known as the Gear VR framework because it primarily focused on mobile VR for the Gear VR. Now it's not just the Gear VR. We support other platforms, all of the Oculus mobile platforms, all of the Google mobile VR platforms, and perhaps any other Android-based VR platform, because we are Android-based and we are Java-based. We're also not just VR anymore. We have AR support for a number of platforms. We are showing ARCore today, but we also support Vuforia. And we have developed some more features that are oriented towards AR, ARCore support being one of them. Also, we have multiple controllers, more platforms. And this feature is near and dear to my heart because I worked on it. We have improved our animation support, and we now can have animated avatars. And we can do some simple animation retargeting to take motions from one avatar and apply it to another. And we have used our very extensible shading pipeline to make different shader models. So initially we started out with the Phong shading model, but a lot of the modern content that's available in GLTF for the web and for even the ARCore platform is based on physically based rendering. It's a different shading model, and we support that as built in as well. So now we have 2 shading models. And we have also made a 3D widget library so that when you make your AR applications, you can add 3D user interfaces to them. So let's look, first of all, at what does the ARCore from Google provide? It has a lot of computer vision underneath, and using that computer vision, it allows you to detect planes, both flat on horizontal and flat vertical, so it's like walls, floors, desktops. And then it lets you tie a virtual point in the virtual world to a real point in the real world using an anchor, so that when you move around in the real world, the thing in the virtual world looks exactly where it was when you first put it there. And we're going to show you real live examples of this in our demo during this talk. It can also do 2D image recognition, so you can put a marker on your desk, like an image that's pretty distinct, and then it can tell you where that is, and you can use that to place little barcodes or pictures and then put objects on the pictures. And you can also render static 3D objects because they have a simple scene manager. They support GLTF, and you can put static objects in your scene. We use the XR SDK for AR because it's a lot higher performance scene graph. It's used to doing VR at 60 frames per second, so we've worked a lot on performance. We support both Vulkan and OpenGL platforms, and we have runtime loading of a lot of different 3D formats, not just GLTF. We can do Ply, we can do FBX, BVH animations. So we use that for our animated avatars, and that's something that AR Core can't do. We can animate objects, and we have support for taking different pieces and putting them together in a consistent animation. So you can put like hats on your avatars or hair or things like that. We also have integrated rigid body physics using Bullet, and we support this spatial audio. We support that resonance audio that's available in Google, just like AR Core does. And I mentioned 3D widgets and our configurable shading pipeline. So if you want to write your own shading model, maybe you don't want physically based rendering or Phong, you want something else, you can actually author your own shaders because our shading, built-in shaders, are authored using that pipeline, our customization. So here's a diagram of the components of the XR SDK. The stuff in the middle is the Java SDK layer. This is what's visible when you don't have any extensions at all to the Java user. So they can import assets, they can handle events from I/O devices, and support a variety of VR and AR displays. We don't have these physics and widgets and all that built in because it would make a bit of bloat if you don't want X3D import, for instance. Why would you want the X3D importer? So the top layer is a set of extensions, one of them being mixed reality, and that is special because it has C++ components. So we can support both C++ and Java extensions. If you're really ambitious, you can write a C++ based extension and provide Java wrappers for it. And users have done that. So now we're going to make an actual AR app here, and Tom is going to show it to you. So first I'll introduce how the mixed reality extension works, what it does for you, and how you talk to it. And then we're going to show how would you do plane detection and anchor tracking in XR SDK. And then we're going to put an avatar somewhere in the real world, and it's going to animate and do some stuff. Now, it may not be the same avatar as in the picture. We have a different one now. It's better. So,
okay, well,
initialization. Before you begin, you have to initialize listeners, because that's how you communicate to SXR, is by event listeners. And there are several different kinds. One is the plane detection. It'll tell you, here's a plane, here's where it is. Another is anchor tracking. It'll tell you when it can see the anchor, when it can't. And then the avatar loader will send you events when you've loaded an avatar or an animation or where things start and finish so that your application can respond to these and do something. And finally, the controller will tell you what objects you've touched. And we're going to show you a little bit about how all these listeners work. And this is the code that you need to pretty much initialize them. You see that it's just hooking up a bunch of listeners. Okay, handling plane events. This is pretty much all the three things that plane events do. They tell you you detected a plane. They tell you that the plane has merged with another plane, which I'm not doing anything about here, but I probably should. And then they tell you when the plane's being tracked or not, so that you can enable and disable the plane tracking. And maybe you hide the object that represents the plane. So you don't have to have all of these planes in your app if you're not using them. And hit testing, this is the way you respond to controller or touchscreen events. So if you're in monoscopic, then it's telling you where you touch the screen. And if you have a controller, like with a headset, then it's going to use the controller for picking. Your application doesn't have to do anything special to get this behavior. It just automatically will do that, depending on what platform you're on. And it'll tell you when you leave and enter a 3D object when you're touching things. So here what we're going to do in our little touch handler is we're only going to look at touch end. We're going to look at where did you hit in the real world. Then we'll get the position of where, put an anchor there, and then when we add that, automatically the XR mixed reality extension will take control of moving that object. So it will move it in the 3D scene to make it appear as if it's always where you just put it. And if you already have an avatar there, then the code at the line at the bottom, which you really can't read, all it's saying is update the anchor pose. In other words, wherever I hit, put the object there now, because I'm giving you a new position for this anchor. So realize that if you want to move an object independently of the anchor, then you probably have to put it under a node so that that anchor moves the node, and then you can move the object and animate it. And that's what we're doing with the avatar that's animated. So here we're handling, did we just duplicate this? I went backwards, I think. Okay, I went backwards, I'm sorry. Okay, handling anchor events. So the only thing anchors tell you is whether they're being tracked or not. So if you had some selection highlight or something in your UI that would indicate that, then you could change that here. Or if you wanted to hide the object when it's not being tracked, you could also do that. And finally, there's the avatar events. Now, the avatar events tell you when your avatar is loaded. And here what we're going to do is we're going to make our avatar 1/3 of a meter tall. So we get the bounding volume of the avatar before we put it in the scene, and we say scale that to be 1/3 of a meter. That's the 0.3 divided by the radius. And then it'll appear to be about doll size, which is what we were looking for in this app. And then we make an anchor there so that the avatar well, actually, that anchor, that line doesn't belong there. I'm sorry. Okay, and then we load the next animation, and then the load next animation will just call it and tell it load animations, and each time it loads one, it's going to start the animations if they're not already started, so that the avatar will animate in a repeat cycle. And that was our live demo. And now Tom is going to tell you more about some of the other technology that goes into this demo and some really exciting new surprise hardware.
Okay. Thank you, Nola. All right. So before I get into any of that, I do want to go over a little bit. So Nola gave you an introduction into how you could create a very simple AR app. Find some planes, place an anchor, animate a thing. And so that gets you up and running. Working along with this is our friends at Cydia, at Samsung in Brazil, that have been looking to take that to another level. And they've created a video for us of an application that they're working on that does more than just put a little dancing guy on a table. So let me play that for you. So what they've created is a virtual pet. They have a menu on the side that allows you to do different operations. So as with a lot of AR things, you can drag, scale, rotate. So they're going to bring the pet closer to them. And then to really one things up, they're bringing multiple people into the environment, all looking at the pet, all looking at the person, teasing the pet with a bone, throwing the bone. Pet's going to go chase the bone. So this is a shared AR experience that everybody can enjoy. And that's just a little sample of what you can do with the XR SDK. All right, thank you, Cydia.
Cydia people, stand. There's Cydia people right here. These are the people you're clapping for.
Okay, next thing I'm going to talk about is the XR Runtime. So first, let me define what a runtime is. So when dealing with head-mounted displays, you need software that can drive those head-mounted displays. Examples of software that drives head-mounted displays are like the Oculus Mobile SDK, the Daydream SDK, Steam VR, and so forth. There is an effort right now in the industry to try to standardize all these different things into what they call an open XR runtime. So we've been developing our own runtime called the SXR runtime that will be an open XR implementation when OpenXR is released. We're an active member in their meetings and contributing and so forth. So we're looking forward to that day when they finally output this spec and we can output our implementation and everybody can just go ahead and use OpenXR. So as I mentioned, this is for driving HMDs, and let me go ahead and move over to here. So in order to test this, we're developing this software. We're a research lab. We're meant to push boundaries, try to see what's coming down the road and develop the software for that and try to anticipate what's going to happen. So there currently is no AR HMD. So we went on eBay and Amazon and Alibaba and bought some random hardware, duct taped it together, and built this. Here, let me hold this up. So this is something you can buy off of Alibaba. The camera is something you can buy off of Amazon. We connected a cable so that it goes right into the phone. The big thing is not so much the hardware. Anybody can make this. The big thing is the software that we've built to put it all together. Because more than just saying, oh, okay, well, I can do a stereo display, you need to be able to do the computer vision, you need to be able to do the tracking, the 6-stop tracking. We wrote some code to interface with the Gear VR 3.0 controller so you have some sort of input. And what we're looking to find out from developers, again, we're trying to find out what's best for development, is what kind of APIs do you need? What kind of interfaces do you need? Right now, what's available out in the market are really, really high-end AR headsets that cost multiple thousands of dollars. We're looking to try to bring that cost down. But of course, in bringing that cost down, you don't have 13 cameras. You have one. So that brings also limitations onto what you can do. So what we'll talk about here in a minute, I'll get into the next slide, is we're holding a workshop tomorrow afternoon where you can come, try to download our software and get up and running. And then we're also holding a hackathon this weekend. So I'll give more details about this in a minute. But all that is to try to test out our Java SDK and our Unity plugin that we've built to be able to support an AR HMD of some sort. And this design is again, something we hacked together. This is not something that's going to be a product ever at all. We're a research organization, but it's something fun to hack around with. So we have a booth. We're in the game section. And so come by there. You'll be able to see some demos that are running on it. And there's a 3D scanner downstairs called HoloLab. We've got at least one or a couple models scanned, so we should be able to display one of those. And come by, talk to us, and let us know what you're looking for. So let me talk about the workshop. So the goal of the workshop, that's tomorrow at River Studios, which is just down the block, is the goal of that workshop is to get developers to download our software and get up and running. We're very, very, very early with this software, so it's not necessarily easy to use just yet. So it takes some patience. So we're willing to hold this little workshop and hold your hand while you get things down and get things running and so forth. So this is kind of the setup for you. So go ahead and take a picture of that location if you like. Okay. And then this weekend we're holding a hackathon. So really, until you try to use something, you never know where the holes or the pitfalls are. So that's where hackathons are great. You get a bunch of people to try to use your software. They say, oh man, this is really great, but I wish we had this. We're like, that doesn't work so well. So that's where these kinds of things kind of get worked out. So our hackathon is being held at our, our close friends at the Silicon Valley VR. They're down in Mountain View, which is actually kind of close to our office. And we have the address up there, so go ahead and take a look at that. The QR code is the current version of our website. We're still working on syncing up the domain of SamsungXR.com to the server, so that should be up later this week. But in the meantime, you can take a picture of that QR code or scan it, and that'll take you to our current Samsung XR website. And then finally, we have all the Samsung XR SDK is open source. So just like with Gear VRF, we're continuing that tradition, and we created new repos. So go to github.com/SXR SDK, and SXR SDK for that, and the demos as well, and you'll get to see what things are there. One final note about the hackathon is we have some pretty cool prizes. So The number one team will win I think it's a Note 9, right? For each member in the team. That's pretty cool. And then the second place team gets a Galaxy Tab 4, which is also cool. And then finally, a Galaxy Watch for the third place team. So we got some cool stuff that, come down, try stuff out, and make some cool things. And give us feedback. That's what we're looking for. All right, I think that's all I've got for my talk. Do you guys have questions? I'm sure you do. Okay. Yeah.
Okay, so my obvious number one question is the Samsung SXR SDK a superset of Gear VR framework? So could I take my code that I've been writing against Gear VR framework and drop it in and run?
Pretty much. So the question is the Samsung XR SDK close or a superset of the Gear VR framework? And it is. So the key differences between the Gear VR framework and the Samsung XR SDK is mainly renaming right now. We changed the package from org Gear VRF to com Samsung XR, and we renamed one of the classes from like scene object, which is kind of long to type, to node. That's nice and short. And everywhere you used to see GVR is now SXR. So that's all you got to do to your code, and it'll just port right over. From now on, we'll maintain, at least for another year or more, we'll maintain Gear VRF in like bug fixing kind of a state, but we'll do all new development with Samsung XR. Okay.
Are you working on a JavaScript SDK in the near future?
Oh, I should. That's something we usually have in our slides. So the Gear VR framework, we did this like 2 years ago. We added JavaScript support to it, and that carries over into the XR SDK. And we have several examples of how to do it. In fact, if you look at SDC presentation I did 2 years ago, I was actually doing live JavaScripting on the phone. So go check that out. Cool.
What kind of objects can we bring in as if we have OBJ or?
So the question is, what kind of objects can you bring in? So we use a third-party library called ASIMP, A-S-S-I-M-P, Asset Importer. And so you can bring in OBJ, you can bring in FBX, Collada, pretty much most of the popular formats. The only thing that ASIMP didn't cover was X3D, and that's something that we built our own extension for, so you can do some interactive stuff with X3D. But I think we actually have a link on our website for what kind of formats ASIMP supports, so you can take a look at that. Okay.
Hey, really cool project. I'm
Thank
curious, what is the use case to use this SDK versus AR Core if you are writing an AR application?
Sure, let me provide
What
some...
devices would you support AR versus AR Core?
Okay, so that was kind of a twofold questions. One was, why would I use this versus AR Core, and then what kind of devices would it support? So first, let me provide a little more clarification on what AR Core actually provides. So AR Core provides the computer vision aspect of things. They'll do the plane detection, they'll do anchors, cloud anchors, so that people can have a shared experience. But AR Core itself does not do any computer graphics. They expect you to do that all yourself. Google has something for doing some computer graphics that is on top of AR Core called SceneForm, but that's in its very early stages. We're a lot more advanced than what SceneForm provides. So, they don't provide animations right now. They don't provide runtime loading of assets. So, we're just a lot further along because we got started 4 years ago. So that's what that does.
Another thing is that SceneForm only runs on phone AR. We will run on AR headsets as well.
Right. And then finally, yeah, go ahead.
Are you only going to run on Samsung devices?
Well, so let me backtrack a bit. So for phone AR, we'll run on anything that runs AR Core. So any device that runs AR Core, you can do the phone AR where you hold your phone up type of thing. It gets more complicated when it comes to headsets, because when it comes to headsets, you need software that specifically drives that headset. And so, we hacked something together so we could have some software or some headset to drive, right? So the software you currently have only drives this thing, but again, this is something you can buy off the internet. I think we actually have a parts list in our booth somewhere, so if you're really that curious, you can buy it yourself. Okay. Yes?
Based on your 3-4 years experience, what would you say are the 3 biggest pitfalls to avoid when starting development on AR and XR and VR in general?
That's a good question. So what are the 3 big pitfalls when starting in AR and VR? So a lot of our experience has been, up until this year, a lot of our experience has been in VR. And this year we've been transitioning to AR. The city actually contributed our mixed reality extension back in like March or April or so. So we've been experimenting with that since then. One of the things that is difficult is scale. That you want things that are real world scale. A modeler may make things that are really actually tiny in units or really big in units. And so that's something that when you bring it into the system, you want to understand what that is. And one of the things that is extra challenging in a headset is, and this is where like my live scripting thing from a couple of years ago comes in, you want to be able to adjust it. You want to take that model, move it, scale it, and position it. Because unless you're wearing the device, you don't know how it appears to the user. You can kind of hold up and go, that's maybe that. But then when you put it on, like, whoa, it's right in my face. So that's a really kind of challenging thing to get is scale. What's another good one?
I would say one of the real pitfalls in any AR or VR development is starting on a very high-end device and expected it to be easy to put it onto a mobile device. It's very challenging, and it perhaps requires you to rework your assets and some of your code and maybe even some of your approaches.
Yeah, so if you develop your stuff on a PC, PCs are really convenient, but they're also really fast. It's like using a supercomputer, right? And then you get it onto mobile, and it's like, oh, this runs at 5 frames a second. Maybe we need to scale this down. So I think that's 2, but I think we have another question. Go ahead.
I noticed that your experimental headset had a USB camera. Are you still able to get sensor fusion with that camera, or are you going through a different approach?
Okay, the question is, are you doing sensor fusion with that camera, or what are you trying to do? So we have a computer vision group in the research lab, and they're also kind of getting used to some of this stuff. This camera is super cheap. It's an RGB camera at that. It's also low res. And so despite all that, they're doing some, I believe it's, do we have any of the computer vision guys in the room here? 1, 2, no? Okay. So they're doing Orb Slam and some of their own algorithms that they built on top of that in order to figure out where the environment is and be able to do 6-stop tracking. Is that? Say again? They're working on plane finding. They actually have a very early version of it, but it's not super accurate. They need to tune that a bit more. Yeah.
So the phone already has a camera, right? Then why do you need that extra camera? And is that 2 cameras being used?
Yeah, so let me maybe demonstrate. I don't have a phone that fits in here right now, but the phone slots in through the top and goes into here and then reflects. And so the front-facing camera, which is the only thing you could potentially be able to use, would then be going through the lens. We did an earlier iteration of this that did exactly that. And what we found was between the coloration of the lens and the distortion of the lens, it made computer vision extra difficult. And so by using an external camera, the computer vision is easier, and you can also upgrade your cameras to do smarter, better things. In the back.
Just wondering how quick is the plane detection, because I do stuff on ARKit on iOS and it's pretty slow. How is it on the AR core?
Oh, well, I still have it here.
Show.
I could actually just show you.
We can just show you because we're using AR Core in this demo.
Right. So let me just make sure that's going to come up nicely. So it's looking for features, and then there we go. So there's the first set of planes. So that was a couple seconds. So.
It seems to go a little high. It likes to put things above.
We also have a question over here when he gets done.
Sure. Because this is so cool. And when you mentioned the rigid body physics engine, what is the use case for using your framework versus writing a Unity program? What are the, versus the Java SDK?
Right.
What are the, if you can talk about that.
So the question is, what's the use case of Java versus Unity, essentially? And it depends on your own expertise and your own comfort levels. If you're a Unity developer, we have a Unity plugin. Use it. If you are an Android developer, what's that? Yeah, so if you prefer Java, then we build it where we plug right into Android Studio. You can go ahead and use it. We have APIs that are very familiar to Java developers. We've been programming in Java for years and years and years on the Android platform. So the things that we provide as APIs are going to follow very naturally. So that's kind of the main thing, is whatever your developers are most comfortable with. Okay. Weird.
Two things. One, can you confirm, so this is like the SXR is like an extension of the Gear VR SDK plus AR Core, and also why not 6DoF controllers too? 6DoF controllers.
Okay, so two things, confirming whether the SXR SDK is a conversion of the Gear VR framework. So the label Samsung XR is kind of just a broad label. So anything that Samsung is going to do with mixed reality, virtual reality, and AR, augmented reality, all that thing falls under XR, right? So Samsung is kind of the brand. Samsung XR is the brand name for that. Inside of there, we have our Samsung XR SDK, and so that provides a Java SDK that allows people to do both AR, VR, and mixed reality. And then we also have a plugin that does that, and we also have a Unity plugin that's an Unreal plugin that's in development. So that'll be a whole suite of things that allow you to do that kind of development. And then 6DoF controllers was the second question. And it's really just kind of time. The Gear VR controller is really easy to talk to. But to do 6DoF, then we would need to find some way to position track it. So you need to either put a marker on it, something that we could track, and then that's always where the line of sight of the camera is. So that provides kind of a limited experience. So it's just a matter of spending more time to do more experiments to see what works well for 6DoF hand tracking. Okay. Oh, okay.
So how about WebVR or WebXR? For the SX.
Right. Let me see if we have some Samsung Internet people floating around the conference.
Yeah, that's a separate.
I'll get to that. I was wondering if
that.
they had one of those guys here, and it does not look like it. So, the Samsung Internet browser, which is on the phone, there's a separate group that works on that browser, and they are actually working with WebXR and trying to enable both VR and AR through the Samsung Internet browser. That's not something that my little group is working on. That's another group. So they're probably better people to answer those questions. And I can put you in touch with those guys if you want. Okay, anything else?
The multi-user experience, was that built using AirCore anchors or some other tech?
I think I'll forward that question to the three people in front here, or actually the person in front of you. Cristiano?
I have a question. It's your question, Christian. Cristiano, you got it.
You got the mic right there. There we go. So the question he asked is the shared experience that you guys are developing. Is that using cloud anchors or some other way of communicating across? Okay.
We are using cloud anchors.
Okay, there we go. Cloud anchors.
Great. Any other questions for our presenters then? No?
Okay, thank you very much.
Thanks.